right. Hey y'all, it's Mr. Kyle, Myers Mathematics, and let's just jump into it. This is a series on series, and we are plotting the first 25 terms of the sequence and stating whether the graphical evidence suggests that the sequence converges or diverges. So if we're plotting, I guess that means we're not really looking for a t-chart. You could use a t-chart also, but you might as well just kind of like have the graph be the t-chart. And if you're able to use a graphing calculator, even better. But hopefully you already know that a sine wave is, well, it's a wave. So it should look a certain way. Let's see if we can graph this sucker. So if I go like this, and it's actually easier for some reason for me to see the little grid lines when I'm not looking at the board, when I'm looking at the other board that shows the... Anyways, so we're going to go like all the way across. And I'm going to try to follow this line. I have a tool that helps me draw a straight line, but it's fine. I'm already here, so. Let's have every other space be 1. I don't know if we're going to do that for X and Y, but maybe. I don't know. Let's see. Where's it? Where's the mouse? I don't see the mouse. All right, hold on. I'm going to like really squint to see it. I need new glasses. So -1 to 1. The sine wave is going to be no more than 1, no less than -1, because it's on a unit circle. If you graph it, the ratio is always going to be a number that's between -1 and 1, inclusive for particular values of n, but not for the not for n values that are like 1, 2, 3, 4, etc., etc. Okay, so and we're in radians. Could I go every other space and get to 25? I don't know. Could I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, let's chance it. All right, so that's 1, 2, 3. Welcome to scrub ahead if you want. 4, 5, 6. Ooh, maybe. I don't know. 7. Yeah, I don't know, because we're already at 7. Looks like we're almost like a third of the way and we're only at 7. Yeah, I don't know. Let's just go like this. Let's see. We'll just find out, and then if it doesn't work, then I'll half it or whatever. So 1, 2, 3, 4, 5, 6, 7, 8. Come on. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, I'm so close. 22, 23, 24. Oh my goodness, it's actually gonna work. Look at this. Oh, it's right on the edge. Oh, that's perfect. Okay, we made it. Oh, ye of little faith. Okay, cool. All right. Awesome. I'm glad that worked out. Okay, so sine of 1. Now, what you can do is, we know that for like certain values, it'll be at the very, very top. And that would be sine of pi halves. But where is pi halves? Well, pi's about 3, so 3 halves is about 1.5. So somewhere at about 1.5 is where it's going to be at its max. And then it's like roughly like that forever and ever and ever. But we want particular values, right? So the sine of 1, if I plug in 1, I get 0.84. So we want to plot these particular values. So there's 1, and then this would be 0.84. So this is 1, comma, 0.84 for that value. And actually, let me use a different color for this point so that I'm not confusing those 2 points with each other. So that's roughly where the max would be at. And then basically I'm not going to graph all of them, I don't think. But basically you would just keep doing that, right? So like you would plug in 1 in the calculator if you're having to use a scientific. Otherwise, I'm just using Desmos right now. So this would be 0.91. F of 2 is 0.91. So it's like really close to the top there. So that's 2.91. And I'm rounding all of these to 2 decimal places. Those are not literally 0.84 and 0.91. It's just approximations. Because they're going to be irrational numbers. So 0.91, f of 2, 0.91, roughly. And then you just keep doing that. And they want you to have the first 25 terms. Yikes. 0.14. That's pretty low. It's like down here somewhere. So that's 3.14. And then for negative 0.75, so about right there, for negative 0.75, and so on and so on. 0 would be at 0, but that's not where you start a sequence at. You start a sequence at 1. So you just kind of do like that. And then somewhere around there is going to be that min value of negative 1, but it's not going to be one of your in values. And yeah, so you would just keep plugging in those numbers. It's a little tedious, but eventually you would get all the 25 terms. Not all, but the first 25. And state where the graphical evidence suggests that the sequence converges or diverges. Now you're just looking at a pattern, so it's not like an exact thing. It's just sort of like, oh, hey, what's it looking like the answer's supposed to be? Which is actually a pretty good idea, and that's what I actually do, is I'll just look at the pattern and be like, oh, it looks like this is happening, so that's probably the answer. Which, of course, is not always the case, but yeah, I mean, unless you know what the if you know about the notable exceptions, then it's fairly safe to just assume like what normally happens is what's happening, and then just remember that there's a couple notable exceptions to the rule, and that's actually usually what I show, because that's probably like the easiest way to do it. If you wanted to get really, really, really technical, then of course it gets more complicated than that, but that's kind of the trade-off, right? So yeah, so you would just plug in all these values, and it's a sine wave, so it's never going to stop waving. It's going to keep waving over and over and over. And we're saying whether the sequence converges or diverges. So another way to ask that question is to say, what's the limit as n goes to infinity of a sub n, aka sine of n? And the answer is, of course, d and e, or does not exist. Because it never levels off anywhere. It never stops going. Think about like Newton's laws and stuff, right? Like an object in motion continues to be in motion unless acted on by another outside force. So for instance, light waves, right? Like light waves can reach us from really, really, really far away, because for the majority of their path towards Earth, they're unimpeded by anything else. Mostly. So those light waves are reaching us because the wave continues to wave. It doesn't decrease in strength because it's not being acted on by any, or mostly any, outside forces. So those light waves are able to reach us. And that's kind of what's happening here. It's like an unimpeded light wave. It's just going to continue to shoot out into the universe forever and ever. So the limit isn't going to be any particular thing, because the light wave could be at the top, could be at the bottom, or anywhere in between. And that's pretty much kind of what they're going for. So just you would plug in the rest of the values, and that's basically it. If you do want to see what those values would be, because you're like, oh, this is like really tedious, I wonder if anybody's posted all the values, maybe I'll put that in the comments down below. Or maybe I'll just wait for somebody to be like, hey, so what are those values? And then I'll respond to your comment and I'll put the values in there for you. I'll do the work for you if you want. I'll just like put all the values in there, because it is a little tedious, right? But just let me know. Give me some feedback in the comments down below. It helps out the channel anyways. So just let me know if you want to see what those values would be, the first 25 terms. Otherwise, I will catch you guys in the next video. Go check out the 5 math mistakes everyone makes and how to avoid them. That is a free PDF guide I made to help you with any math class you're in. And that link is down in the description below, myersmathematics.com. And yeah, see y'all next time. Blessings, y'all.